So the first thing you must get at is this is by successive differentiation. Okay. You of course can use you can use standard series here. Okay. You know why you can use standard series? Because this is 1 over cosine 2x ma. You can use standard series. But since you were told to find f prime and f prime prime, you might as well just use successive differentiation. Okay. So this first one, answer your question, right? What you get is this fx is secant 2x. It will be f prime x. You can use MF26, right? This will be secant 2x tangent 2x times 2, right? Okay, MF26. Differentiate secant is secant x tangent x. So then differentiate again. Wow. This is quite tedious. 2 secant 2x secant square 2x. Times 2 plus tangent 2x 2 secant 2x tangent 2x times 2 again. A lot of 2's around. So let me color code it for you. This is u, this is v, u dv dx plus v this will be four yep. So should be quite fast. 5 marks. Yeah, quite. So f0 1 over cosine 0, which is 1. F prime 0. Key in calculator. 0 should be 0. F prime prime 0 will be 4. 1, yeah. So hence fx okay. So check your answer. How do you check? Same thing. Graphing calculator, just key both of the equation and hope that it looks the same. I think it will look the same. So just go to your calculator here. Then you just key in 1 over cosine 2x. Then you just key in 1 plus 2x squared. Okay. Before you even start, you just try and check your answer first. Just chill. So it looks promising. There you go. This middle here. The estimated curve, yeah, there you go. It touches there. So you zoom in there, zoom box. You can zoom box to that region. Enter like that. So the estimated curve is, I can be sure, is quite correct lah. Oh. You have you have to have the mental frame that this is the estimated value. This is the correct value. Okay, so 5 dp. Then this is the amazing part lah. So part 2. Here. 0 to 0.02 secant 2x dx is 1 plus 2, 0.02 square. Estimated. Oh, sorry. I did wrongly. 0 x plus x cubed 2 over 3. Okay, 0.02 1. 0. Did I do anything wrong? No, right? So 0, 2 cube. In calculator. Will be 0.20. So they want 5 dB, right? 1, 2, 3, 4, 5. Then part 3 is just keying calculator. Quite straightforward. This will just be math 9 0.02 cosine 2x. This is x here. Yeah. Okay. In this case, you can just use x. But if you want to use a alphabet, also can. But 0.020053. So this is 0.02000053. Amazing, right? The accuracy. So why? Why is it so? 5 dB. Okay. I write 1, 2, 3. 1, 2, 3, 4, 5. So hard to write. Okay. Okay. The question is, right, how come there's no margin? Why is no error in the answer? Okay. So for part, let's try and entertain me, okay? So this one here, percentage error is 0, right? If you consider two of these, right, it's 0%. It's totally 0%. There's no error, Okay, there's no error in it. So the rationale is why is it so? Okay. Now first thing is look at this one. To evaluate the integral, you need x cube, right? Agree? Right? So we look at x cube. So let's look at x cube. Because when x equals to 0.02, x cube equals to is what? 0.02 to the power of 3, right? Which is actually 8 times 10 to the power minus 6. This is actually how many dB? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. This is 6 dB. Agree? Any issue with that? This is how many dB? This is 2 dB, right? You see that when you cube it, right? This is 6 dB. Okay, what does it tell you? It tells you that x to the power of 4 and above will be, and above, right, can be ignored. See that? But because your answer asks you to express in 5 dp, you see that? And because x to the power of 3 is 6 dp, so of course it'll be accurate lah. I repeat, the rationale is very simple. You look at this x cube here. If you're using 0.02, which is very close to 0 lah, and because 0.02 cube, right, to evaluate this root, right, cube, right, it will be 6 dp. So in other words, 7 dp and above, right, is actually not relevant in your estimate. So that's why the estimate is accurate. Okay, so that's the rationale. That is what the question is trying to ask. They're asking how come it's so accurate. Okay, this would then be this is how, right? So since let me see how to write. It's needed. This is what I'll write. I'll try and argue that because in our integral, x cubed is the highest degree. So if it's 0.02 is actually a 6 dp. Okay. And since x4 and above are ignored, meaning 7 dp and above, thus the answer and 2 and are the same as they are corrected to 5 dp. Yeah. Hence making the approximate very accurate. That's how I would think about it. Okay. So small angle up, small values. Maclaurin series, we take very, very small values because very, very small value will be highly accurate because it's close to 0. Maclaurin series is a Taylor series. Essentially just a subset of Taylor series is here, right? Maclaurin is here. Taylor is not in your syllabus. Okay. So what Maclaurin series does is you just approximate equation curve which is from x equals to 0 lah. You always start from x equals to 0. That's why all your equations are x equals to 0. So for part 4, Maclaurin series cannot approximate a curve when you have a vertical asymptote at x equals to 0. Okay, because cosine secant 2x, right? The graph looks like what? Cosecant, it will look differently. It will look at the graph there. 1 over sine. You actually know how to sketch this graph. It looks like that lah. So you just 1 over sine 2x. Okay, then graph it. So I see some of the solutions say undefined. Okay, right? I think some of the, I don't know, I saw online someone say that because it's undefined, x equals to 0. That's not a really mathematical way of saying it. The correct way of saying it is that since cannot be found because G is not a continuous function. This is the mathematical way of writing. Because it's not a continuous function at x equals to 0. Not because it's undefined. I mean, you can say it's undefined. I think they will still accept the mark. But if you want the y, the y is because it's not continuous. It's not a continuous. Because g is not a continuous function at x equals to 0.